Hello everyone. In today's video, I'm going to show you how we can determine land suitability for a particular crop. In my case, I'm showing you here the land suitability for coffee production. First of all, as usual, we're going to set a directory and then load a package, SF package to read shapefile, deep layer package to rearrange our data and to calculate some basic summaries such as mean and median values if it is necessary, and anyhow to rearrange data and Terra package to read raster format files. So I load Terra package. So I'm here reading the shapefile from my specific route, that is Ethiopian shapefile. Of course, I can calculate or determine land suitability for coffee as a whole country for Ethiopia, but the machine that I'm using is a little bit slow, and I prefer to do that for a particular smaller region. But the same principle can be applied for any region either, or as a country, or for different countries as well. So now I select from Ethiopia Sidama region, which I use as a shape file to determine for that particular region. Then I use that and transform that shape file after filtering into the different coordinate, projection system to make similar with the other data coordinate projection system too. Then after doing this, I read different data that is important for determining land suitability for coffee production. Rainfall is one of the key variables that helps us to determine land suitability. The other is temperature. Temperature, we need for sure a mean temperature here, but I used maximum and minimum temperature to calculate a mean temperature here. Sorry. And the other variable is normalized vegetation index. That is maybe shows the how really healthy the vegetation in that particular area is, if there is disease, if there is any other problem. That shows us maybe if the healthy vegetation is located in particular area, that area could be a potential for coffee growth. So I read this file using Rust function, which is in Terra package. So these files are in a netcdf file format, but that can be directly read as a raster file that can be downloaded from Terra Climate for this particular purpose. I'm using temperature and rainfall from Terra Climate. Of course, we can use this data set is like high resolution data set, but it has its own limitation. We can use the most highest resolution and highest standard available, and our output also could be more reliable in this case. So I read a temperature, maximum temperature and minimum temperature, and normalized vegetation index. To calculate mean temperature, I use like maximum temperature that I read here, and minimum temperature I add 2 of this, and I divide for 2. Then to download elevation, the other very important variable for coffee production is elevation, and to download elevation here. I use Elevator package, which can provide elevation of the whole, I mean, globe. So from this, we can simply download using gate elevation raster, and we provide location. Location in my case is Sidama region. I put as a shape file here. Then I also select zoom level of that location, and I selected 10, and you can choose whatever you want. So that takes a bit time depending on the connection. That's your connection. You can see here it's downloading. In my case, it's like as fast as I can think. And then after doing this, we crop our file. This file is not cropped for particular region. So I crop rainfall to my particular region here. And then I mask the other area around, and I can see, I plot and see whether it is there or not. My case, I am plotting now. I think that will work. Okay, of course, I calculated the time. This is how far it is there, and now I'm actually calculating the mean annual rainfall. I need only mean annual rainfall. From that, I calculate average for long time, like from in my case, it's from 1981 to 2024. Then after calculating mean, I'm going to plot and see this is how rainfall looks in Sidama region. And then I do the same for temperature, and then I plot and I see, like, for average temperature looks like this. And then the other is like to see also the minimum temperature in this case, and I make sure that whether there is any in this data set. If there is none available data set, we need to remove, otherwise it can cause a sort of problems. So I see their projection, how its projection looks like. I see also the extent, how the extent, it's whether it is covering Sidama region or not. So afterwards, I crop also on normalized vegetation index to Sidama region. Then after doing this, I make sure that all are in the same projection. Otherwise, I cannot compare or I cannot work. To do that, like for example, rainfall, I make rainfall into the projection of dam. Dam is like only elevation, so I put like all variables to the same elevation. The same projection. So unless and otherwise they are not in the same projection, we cannot compare either, or we cannot calculate at the end of the day suitability from a combination of these variables. So I need to make this for all of them, and the dame is into also raster. Then I make sure also interpolating into the same actually the same resolution. Like the dame is, in my case, is the highest I think resolution. So I put all of them into the same resolution. Now NDVI is the highest resolution, so I put all my data into the highest possible resolution, which is nearly like less, in certain meters. So I put this. So this resampling is to interpolate data into the resolution that we want to have. So that takes some time to interpolate. And after interpolation is done, we're going to see, like, we're going to plot how temperature looks like, and like it looks like this after interpolation, and this looks like this is very high resolution. You can see like almost everything out there, and then we can see like how vegetation index also looks like. It looks like quite realistic, and it shows almost everything. So we put these four variables into the same list here, like a raster list. Then after putting them raster list, we're going to separate that list. And now the basic thing here is that we have to set the suitability classes. We classify our every variable, for example, temperature, for temperature, suitable temperature for for coffee production. We classify each of these, and we multiply with the the level of importance of this each variable, and then we put them together. So the first, like, less than 15 degrees Celsius, the coffee production is like, it's too cold for coffee production for sure. The average, between 15 and 18, it looks like it's not that suitable, but it's okay. Coffee can be produced, but not really conducive. The conducive one is between 18 and 22 is very suitable, and 22 and 24 is a little bit too hot for coffee production. This can be, of course, you can look the optimal temperature for coffee, and based on that you can set your suitability, temperature suitability for coffee production. This is actually up to your ingenuity. How you're going to set the level of suitability, and how you're going to cluster. It's actually based on your choice, and based on literature you can set that. Based on the optimal temperature of the crop, you can set that. So I set into this, then I plot and see that one, how it looks like. It takes some time. So based on that, this area is too cold for coffee production. Of course, I know most of these areas. These areas, of for sure, some of these areas I know, and it's cold as well. And the other areas now maybe started producing some coffee, but this area is very important for coffee production, suitable based on temperature. So based on rainfall also, we decide like less than 1,200 millimeter annual average rainfall. That is too dry, and between these two is okay, but it's not really sufficient to support coffee production. But this amount of rainfall is sufficient, so we classify this as well. Then we plot and see so how it looks based on rainfall. This area, over this area, rainfall is looks somehow quite high, and this area is quite conducive, and here also, not bad. So then we see again. So that is rainfall based on altitude. We can see the altitude 1,200. Below this is quite dry for coffee, and between like 100,000 and 1,200 and 1,500, it's okay, but it's not really good altitude. But between 5,100, 1,500 and 2,200 is optimal. It looks like very nice, very productive altitude, and we plot that one as well, and we see how altitude of the region looks like. And this is, yeah, for sure. I know this altitude is too high, like mountain areas. These areas, I know that is not really producing coffee right now. That is how you can classify based on this. And other one is uh, a normalized vegetation index. Of course, like if there is less than zero point 0.4, that is really dry area, and that is like somehow bare land, or like land for, I mean, for other purpose, other use. It's not agricultural land anymore. And more than less than 0.4, between 0.4 and 0.6, it's somehow it's forest, not really a forest, but it's a little bit like a sort of bushy land. And for that land, like it could be like a flat land or grassland. For that, yeah, on that land also coffee can be produced, but anything more than 6 is like classified as forest land. Of course, coffee is also a part of forest, and it needs shade for, I mean, production. Good quality coffee can be produced under the shades, and that like a big trees could be preserved in the forest. I mean, in the coffee, to give a shade for coffee. So this is how I classified. Then I put maybe this together, and then I mask. So after masking this, I plotted also like the normalized vegetation index. Based on normalized vegetation index, the areas that can grow coffee is like most of the areas in the region. Then I crop all to the region. After that, I give like which variable is really important. Temperature is highly important, so I assign like the importance value of 35 for temperature, 30 for rainfall, 20 for altitude, and 15 for I mean normalized vegetation index. Guys, this is up to you to actually use different numbers. Which variable is really important for that area? If temperature is not really important, as such important, you can use altitude. You can give like higher importance to the altitude. This is somehow like weighted value, and you can give more weight for rainfall or for the other variable. In Sidama region, rainfall is, I think, sufficient enough to support coffee production. But some areas, temperature is, of course, temperature depends on the altitude as well. And there are also interdependent variables, even though, I mean, we use different, different weight. So in this case, you can determine the importance of these variables also based on the literature poorly. You have to read thoroughly literature, and you determine which variable is really important for coffee production, either temperature, rainfall, or any other variable. So based on that, you give high weight for that particular variable, and we add this all variable together, and we produce coffee suitability here. So coffee suitability is now produced. Then after that, we going to classify this into different, actually, which one is unsuitable. If something is lower than 3, positive 3, that is not that suitable, sorry. And if something fell in between 3 and 6, that is moderately suitable. Any value that is higher than 6 and lower than 1. Of course, this thing goes from 1 to 0 to 1. I mean, like after calculating this weight, the weight goes from 0 to 1. Then 1 is highly suitable, and the rest, the lower ones, are somehow less suitable. So that is it. Then after doing this, we're going to get into the plotting. Now we have data, we have a cluster, we have a classes, which class is suitable, which class is not suitable based on the weighting factors, weighting of different variables, and actually we calculated the classes. Then we change this raster value, raster classes, into a data frame using as data frame function, and we give the same name that we assigned here, this name, and we make x, y true. X, y true is like simply to keep our altitude, our latitude and longitude values, and if there are any n a values, we ask R automatically remove that one. So this is how we convert into data frame. Then after converting data frame, it could have like XY and different name for this. So we make this like the name that we can easily understand, column in names, X and Y. X is here longitude, and Y is latitude, and class is like the value that we got from classifying. Then after here, we again assign the values here. The first one is unsuitable, the second one is moderately suitable, and the other is highly suitable. And we ask R to assign the value for classes, to give classes 1, 2, 3. The lower one, like 0, between 0, we assigned already here, like between 0 and 3 as a 1. Normally that is unsuitable. This is as a middle, that is moderately suitable. We assign 2, and anything more than 6, that is highly suitable. We assigned for that highly suitable. So that is the value that we read and we put together. Then we give color. If it is not suitable, we color as red. If it is moderately suitable, we color as yellow. And if it is really suitable, highly suitable, we assign a green color. Then we read this into R. For plotting purpose, we need GG and geospatial package. GG package is anything that plot using GG. I have actually another video which explains how GG a package works, and what are really important, the skeleton for plotting using GG plot. GG plot is very interesting plot for visualization in R. Particularly like plotting and making maps or making any fancy graphs. It is very important. But GG spatial, we need, for example, for spatial analysis, we need use arrow and scale here, scale bar. For that, we need GG spatial. So I call both of these packages. I assign the plot here. So I plot like I call GG, and that is a raster, and I call like coffee data frame. Coffee data frame is the frame that I give here. The first x-axis is longitude here, that is x. The y-axis is latitude here, that is y simply. And I assigned the internal value as a class, and then that is the basic thing. Other thing is only like addition on top of this map. So then we can plot this map now. We can run our map. You can see, I mean, the other basic things there. So I can put like which plot, coffee plot, I think. Coffee, coffee plot. That is the name of my plot. Then we can see it takes a little bit time because that is very high resolution and it needs I mean a processing time, but it comes here as a plot. So meanwhile, how you can save this for publication quality graph, you can use ggsave and file name. And what I mean, file name can that be saved? You can put this here, file name that you want in your desktop or in your, I mean, the folders that you are working is this one. Here, what we are working, like what name we have assigned here is, as you can see, the coffee plot is the plot that I produced it here. I put that one. I determine width and height, and then the resolution of the print on. Yeah, here is the nice map actually. So this is how we can produce, I mean, the quality map for land suitability. Of course, we can determine different things, and I will show you in another video another thing. I will put this I mean code under the description of this map. The link of the code, I mean, I put this code in GitHub for your personal use, and you can use it. It's free, and please don't forget to subscribe my channel and make on the bell icon there, and so that you can get maybe update whenever I upload any video important for you as well. So thank you very much. That is it for today.